Hello everyone. This lesson is on angles of polygons. If you recall what a polygon is any shape that has straight sides. Um, could be 3 sides, could be 100 sides. Polygon is just any shape that has all straight sides, and it has to be like an enclosed shape. Now there are two different types of polygons. Um, what we're going to be talking about today is our convex polygons. Um, so just kind of quickly go over what the difference in the two are. Convex polygons would be polygons that have shapes that all of the angles are on the outside of the shape. So, um, if we were to draw a shape, so a convex polygon, all of your angles or all of your vertices of the shape are kind of outside of the shape. So that would be an example of a convex polygon. Okay. Um, opposed as opposed to that would be a concave polygon. Okay, so a concave polygon would be one that has what I call has a side indented. So this would be an example of a concave polygon where you kind of have this cave um, inside the polygon, where this vertex is actually located kind of inside the shape. All right, so those are two different types of polygons. Um, Again, what we're going to be focusing on are convex polygons. Everything that we look at today involving the angles are in regards to convex polygons. All right. So our objectives for today is to find and use the sum of the measures of the interior angles of a polygon and the sum of the measures of the exterior angles of a polygon. Um, so what we're going to start off doing is looking at the interior angles of a polygon. And if we start off with the common polygon that we've already talked about, and that would be a triangle. So we already know that a triangle, if we add the interior angles of a triangle, so angle 1 plus angle 2 plus angle 3, we know that equals 180 degrees. Okay, so that's for any size, any shape triangle. The three interior angles sum is always 180 degrees. And that's useful when we look at these other polygons um, because we're going to use that fact or that knowledge, that prior knowledge that we have. So we're going to transform this triangle into a quadrilateral. So quadrilateral, quad means four. So a quadrilateral is any shape that has four sides. So I'm just going to quickly draw a four-sided shape. This one isn't any particular special quadrilateral. It's just any generic four-sided polygon. All right, so what we do with this is if we take this polygon, let's call this quadrilateral ABCD, and we pick just one vertex of our polygon. So I'm just going to pick vertex A. And what we're going to do is we're going to draw diagonals across this polygon, across this quadrilateral from that vertex to the non-consecutive sides. Well, the consecutive sides would be side AB, side AD. So we're going to draw it to the non-consecutive vertex. So that would be over here to C. That is a horrible line. I'm going to use the line tool to do this so we can make it a straight line. So there's my diagonal. The diagonal is any line that connects two non-consecutive vertices of a polygon. All right, so what this does is it splits this polygon up into two triangles. So I've got this top triangle up here, this bottom triangle down here. Well, each of those two triangles has the three angles in it. Okay? And each of those two triangles, the sum of those three angles is 180 degrees. So essentially I have two triangles times 180 degrees for each triangle. So that means that every quadrilateral sum of the interior angles is 360 degrees, no matter the size or shape. Okay? So we use that in different types of problems that we'll look at. So the next example would be, if we do that with, say, a five-sided shape. So let me add another side to this shape. So, all right. So I'm going to do the same thing. I'm just going to pick one vertex. I'm not going to name all of them. I'm just going to choose one of the vertices of this shape. And I'm going to draw all of the diagonals from that vertex. So I'll draw one across to this corner. If I can get it to quit snapping there. Can't get it to stop snapping, so I'll just adjust it a little bit. All right, so I've got that diagonal. Now I'm going to have this diagonal. Down to this vertex. And what that does, it splits my triangle up into three triangles. So that would be 180 degrees for this one, 180 degrees for this one, 180 degrees for that one. So then that's going to give us a total of three triangles times 180 degrees equals 540 degrees total. Right? So that means that every 1, 2, 3, 4, 5-sided pentagon, or 5-sided polygon, which is called a pentagon, the sum is going to be 540 degrees. So that means if I go through here and I take this angle plus this angle plus this angle plus this angle plus this angle, add all five angles up, they're going to total 540 degrees. Right? Well, if we look at our pattern here, what our pattern means, or what we get for a pattern, is the total number of sides that we have. Right? If we look at the number of triangles that can be created based on the number of sides, it's always going to be two less triangles than the number of sides. So that means if I have a six-sided shape, that means I can create four triangles inside using this method. All right, so then for any six-sided shape, I would have 4 times 180 degrees equals, that, I don't remember what that is. Top of my head, I'm drawing a blank. 0 to 720 degrees. So every six-sided shape is, the sum of the interior angles is always going to be 720 degrees. All right, so that's our rule, that's our pattern, and that's going to lead to our formula. So our formula is going to look like this. The sum of the interior angles of a convex polygon, so the interior angle sum of any convex polygon can be found by the formula n minus 2 times 180 degrees, where n is the number of sides. Okay, so the interior angle sum can be found by the formula n minus 2 times 180 where n is equal to the number of sides of the polygon. Okay, next video I'll go through and show a couple of examples of how to use this formula to find angle measures inside of polygons. All right, thanks for watching. If you like the video, thumbs up. Comment if you have comments on it. If not, stay tuned for the next video. Thanks.